Okay. Now this question is a kind of a tricky question because they have not given an acceleration. So they are telling the object is moving at 10 ms minus 1 only. So it means that object is moving at uniform velocity. Object is moving at uniform velocity. So if the object is moving at uniform velocity, the acceleration will be 0. So therefore, there will be no unbalanced force. If the object is moving at uniform velocity, there will be no unbalanced forces. That's why I put 0 here, because it is moving at 10 ms minus 1 velocity, uniform velocity, not an acceleration. So therefore, for the objects which are moving at uniform velocity, there are no accelerations, no unbalanced forces. Question number 8. Okay. The velocity of an object was increased from 8 to 18. So this one we have to draw a small diagram. Starting velocity 8, ending velocity 18 in 5 seconds. Time equals 5, right? Due to an unbalanced force. Its mass is 50 kg, but it's the unbalanced force. First of all, we have to find the acceleration. So the acceleration equals final velocity minus starting velocity divided by 5. 18 minus 8, 10. 10 divided by 5 will be 2 ms minus 2. Then apply the formula. F equals ma. Mass is 50 kg. Acceleration is 2. The unbalanced force acted was 100 Newton. So some data are hidden. So this is how you obtain the hidden data. Using the hidden data, you have to calculate the acceleration. First, you have to get the acceleration. Then, using it, you have to calculate the force needed, unbalanced force. So all the 8 questions we have done. So you can write the answers. You can check whether your answers are correct. හරි මම හිතන්නේ ටික লীලා ඉවරයි. අපි යන් ලෙසන් එක ඉස්සරහට. So now we have the Newton's third law, the easiest one among the 3 laws. So it says every action has an equal and opposite reaction. Here, you can write the third law. For every action, there is an equal and opposite reaction. So that's the Newton's third law, where you can write. But now in your tute, there are two words, action and reaction. There are two words, action and reaction. For action, you can write like this. In front of that action on a dotted line, you can write within this one. The force exerted by an object on another object. The force exerted by an object on another object. So then go to that reaction thing. In front of the reaction, you can write like this. The force exerted on the first object by the second object. The force exerted on the first object by the second object. මම කියපු ඒවා මෙතන sentence එකේ තියෙනවා. Action එක මෙතන තියෙනවා මේ sentence එකේ බලා ගන්න. මෙතන තියෙනවා. මම මේ තියෙන dot එක තියලා තියෙන තැන තියෙනවා. Force exerted by an object on another object. Action reaction දෙකම මෙතන තියෙනවා. බලාගෙන ලියන්න පුළුවන්. Now, the motion of certain objects can be explained by the Newton's third law. Now, for an example, the movement of a rocket that is based on the action and reaction. Then movement of a skycracker, right? Action reaction. When we walk, again action reaction. When we swim, action reaction. Rowing a boat, action and reaction. Newton's third law. Then again, when you let go an inflated balloon, it moves. Again, there'll be action and reaction. It is complying with the Newton's third law. When you are seated on a chair, action and reaction. Again, following the Newton's third law. Okay. Now here, this is the story of the inflated balloon. Right? Once you let go the mouth of an inflated balloon, you will see that it flies away. Right? So the action, there will be a force by the balloon on the air molecules downward. That is the action. By the balloon on the air molecules downward direction. That is the action. Reaction by the air molecules on the balloon upward. So by the reaction, the balloon is thrown upward or sideways. So I'll write the action and reaction. You can copy it down. So this is the action and reaction for the movement of the balloon. So the action by the balloon on the air molecules downward direction, reaction by the air molecules on the balloon upward direction. Okay, so you can write action and reaction with the given spaces of the balloon in front of the balloon. Okay. So there are some other examples. Right. Then this one. Now again, this is also another type of a balloon. So you may have seen that there are long balloons which are sold in the buses. So the vendor comes to the bus and inflate it, and he again let it go. Then it will flow here and flew here and there in the bus. This one, first of all, we have to make or to stretch a cable on two different locations, and a straw is inserted. So the straw can freely move along with the wire, and the inflated balloon is sellotaped onto the straw. So once you let go the opening, there will be air blowing out of the balloon, and the balloon starts to move into the opposite direction. So this is complying with the Newton's third law, action and reaction. So the action will be by the balloon on the air molecules left direction. Then reaction will be by the air molecules on the balloon into the right direction. Oh, my way. All right. Okay. So we'll write action. You can write action. Action by the balloon. By the balloon. By the balloon on the air molecules. By the balloon on the air molecules. On the air molecules into left direction. Into left direction. Into left direction. Reaction. Reaction by the air molecules. By the air molecules. By the air molecules on the balloon. By the air molecules on the balloon. By the air molecules on the balloon to right direction. To right direction. And now look at this example. Now here, two students are seated on planks of wood. So they have kept some, there are some marbles kept under the planks, so they can be easily moved here and there. So they keep their hands like that and push each other. So as a result, both of them will be thrown into opposite directions. Both of them will be thrown. So that is because of the action and reaction. Now, in this case, it is difficult to mention the action and direction and action and reaction. So therefore, we'll write a sentence in general, right? We can write something like this. When the boys push each other, 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 they will be thrown, they will be thrown, they will be thrown to opposite directions. They will be thrown to opposite directions. They will be thrown to opposite directions because of the action and reaction. Because of the action and reaction. Because of the action and reaction. All right. Now comes to the application 4. As I told you earlier, rowing a boat, again, a type of application for the Newton's third law. Now, when you are rowing a boat, we put the oar into the water and push backward. So the action by the oar on the water backward. That is the action. Then the reaction will be by the water on the oar into the forward direction. Okay, we'll write action. We can write the action by the oar, OAR, by the oar on the water, by the oar on the water backward, by the oar on the water backward. By the oar on the water backward. So the reaction by the water on the oar, by the water on the oar to the forward direction. To the forward direction. To the forward direction. Okay. Now this is the application 5. When we walk, the Newton's third law is being used. So have we ever thought how we walk? So this is how we walk, right? Let's try to understand. So when we are walking, right, there will be a force right? When we are walking, we keep the foot on the ground and push backward. So action is like this. So we are being pushed forward by the reaction, which is the friction. Unless friction is not there, we'll be slipping, right? So you have to draw the diagram. You can draw the diagram in that box. Right? Action and reaction. Action and reaction. Action by the foot on the ground backward. Reaction by the ground on the foot forward. By the ground on the foot forward. So you can write the action and reaction also along with that. Sorry. Okay, action, reaction, done. Now we come to the another concept of momentum. So the momentum is an idea of concept how difficult it is to stop a moving object. How difficult it is to stop a moving object. And again, the momentum is equal to the product of mass and the velocity. Product of mass and the velocity. So the momentum, you can write this sentence. This one. The first sentence you can write. It says, the momentum of a moving body is a measure of how difficult it is to stop the motion of that body. So you can write that in that box. Okay. Now, for an example, now just think our school building. Now, this is 4-story tall, right? So if we keep a student in the ground, on the ground, and we drop a tennis ball for him to catch, he can easily catch it. No problem, he can easily catch it. But if I drop a leather ball, then the situation is little bit difficult now. We need some special technique for catching it, otherwise you will hurt your fingers. If I drop a full coconut, then situation going to be even worse. It is nearly impossible to catch it because it contains more momentum. So when you think of the leather ball, it has a greater momentum than the tennis ball, and the mass of the coconut is more, so therefore it has the highest amount of momentum. So when the momentum is increasing, it is difficult for us to stop the object. That is the basic idea. Okay. Momentum of a force depends on both mass and velocity. Here you have to write momentum of a force, not force. Force නෙමෙයි momentum of an object කියලා දාන්න. එතන spellings පොඩ්ඩක් වැරදි හදාගන්න. Momentum of a force නෙමෙයි momentum of an object depends on both mass and velocity. Momentum of an object depends on both dep and ds, depends on both mass and velocity. A tennis ball falling from a height of 10 meters is easily catchable, but a coconut falling from same height is difficult to catch. Example. The formula of the momentum can be given as follows. Formula එක මෙන්න මෙමය හදන්න. ඒකගේ textbook එකේ තියෙන විස්තර ටික ලියා ගන්න. Momentum equals mass into velocity, p equals m into v. P equals m into v. And again in the same box you can write the units. Mass is kilogram, velocity is ms minus 1, so therefore the momentum kg ms minus 1. So all these things should be written in this box. Box since the velocity is a vector, momentum is also a vector. I load the page, you can write it in that box. හරි ෆෝමියුලාස් ටික ලිව්වා. මේ ටික ලියන්න මේ නිල් පාට බොක්සස් දෙකේ තියෙන විස්තර ඔක්කොම එතන ලියන්න. හරි. මේක ලියන්න ඕනේ. ඊට පස්සේ ඒක ඉවර වෙච්ච කට්ටියට මේ එක්සර්සයිස් එක කරන්න පටන් ගන්න පුළුවන්. හරි. ෆෝමියුලා එක දාලා හදන්න. Okay. So we'll do the questions. A man with a mass of 50 kg moving at 2 ms minus 1, find momentum. Equals mv, mass 50 kg moving at 2 ms minus 1. So you answer 100 kg ms minus 1. So this is how we do it. The unit kg ms minus 1. Check whether your answers are correct. Right. Next question. An object moves with a mass of 50 at a velocity of 200 ms minus 1 momentum. So the mass is a very small value, 50 grams. 50 divided by 1000, the velocity 200, maybe like a bullet. So 200 times 1, 200 times 5, 5 times 1, 5 times 10. So you answer 10 kgms minus 1. 10 kgms minus 1. Third one, a bullet of mass 10 gram traveling at 300 ms minus 1. A large lorry of mass 15,000 kg moves at 0.25 ms minus 1. Which of them has a greater chance of knocking down a wall? හැප්පුණොත් එම පිටියක් පෙරලෙන්නේ bullet එක වැදුනමද lorry වැදුනමද අහන. ඉතින් අපි හදන්න ඕන P equals mv 2 times දාන්න ඕන. Mass of the bullet 10 grams divided by 1000 multiplied by 300 ms minus 1. 3 zeros වලට මේක ගියා answer 3 kg ms minus 1. Then here P equals mass 15,000 multiplied by 0.25. So the 15,0.2 වැඩි කරලා බලන්න. කියන්නේ 15,000 බෙදීම 4නේ. So 3,750 3,750 kg ms minus 1. We say P, this is P2, this is P1. So P2 is greater than P1. Therefore, lorry has a greater chance. Lorry එක තමයි හොඳ. මොකද value එක ලොකු කෙනා තමයි better. තුවක්කුවකින් වෙඩි තියලා තාප්පයක් ගිහුණා. lorry හේතු නැත. Right? Okay. So this is how you do the question. You can write it down. So this divide by 1000 is to convert the 10 grams into kilograms.